this section, chapter 11, is about rational and irrational numbers. So let's review what a rational numbers were first. Who remembers what rational numbers were? Anybody? Yes, sir.
Numbers that exist.
Well,
Rational?
yeah, rational.
Yeah. Just a number that exists.
Exists? No?
Oh, I
No. Yeah, what do you think?
It's a number that you can express as a fraction.
That's correct. It's a number that you could write as a fraction or call rational. Well, yeah, so some numbers you cannot write as a fraction, so you can't.
Who said that's like every number?
So then, who remembers? Guys, write this down. So some examples for these rational numbers are 0.3333. Is that a rational number? Yeah, 0.3 that repeats forever. It is a rational because you could write it as a fraction, can't you? 1/3. So that's one of the. And then 0 is a rational, isn't it? And of course, 1, 2, 3, negative 1, 2, 3. Like 1 is a rational because 1 is really 1 over 1, right? How do you write 1 as a fraction? 1 over 1. 5 as a fraction. 5 over 1, and so forth. What are then irrational numbers? Yes?
Numbers that can't be written.
Exactly. The numbers that you cannot write as a fraction, right, are the irrational numbers. So how many irrational numbers do you guys know of? Can somebody give me some examples of irrational? Yes. Pi would be one of them because pi, it goes on forever, the decimal place, right, without repeating. Yes.
The square root of 2.
Square root of 2, also a number. It goes on, the decimal place goes on without repeating. If it repeats, is that a rational or irrational?
Irrational.
It is a
Rational.
rational. Any time when the decimals repeat, okay, you could always write as a fraction. We'll learn that later. Okay, but from one example, we just gave it to you. 1.3333 forever is a 1/3 and so forth. So here are some examples of irrational. Pi will be one of them. Square root of 2 or negative square root of 2 or negative square root of 3, positive square root of 3. And I could, write. What about square root of 4? Is that a rational? No. Square root of 4 is a rational because what is square root of 4 really?
2.
Yeah, it's 2. And 2 is really 2 over 1, you see? So, that's how we get it.
8 is 2, right?
Sorry?
The cubic root of 8.
Yeah, cubic root of 8 is 2. That is also a what? What is cubic root of 8? Is that rational or irrational? That's rational. Cubic root of 8 is 2. So it is a rational. Any questions? This. What about square root of negative 2? Or like, I don't know, 2 over 0. Is that rational or irrational? It is. Pecco? Yes, so it is. One of them is. Not everything is imaginary. So it's either rational or irrational. So that's why we say they are undefined. Okay, they're not defined. So they're either rational or irrational. So write this down, guys. Hold on.
All numbers that aren't real undefined. Like not real.
Yeah, for now we're gonna say that. Okay, so look. All real numbers are made up of rational or irrational. In other words, you see the number line? Every number on the number line is if you were to pick a random number on a number line, it'll be either a rational number or a irrational. Okay?
Wait, does that say all numbers and made up of?
All are. All real numbers are made up of rational or irrational numbers. Okay, so they're either negative number like negative 3. Is that a rational or irrational? It's rational because negative 3. Could we write that as a fraction? Yeah, negative 3 over 1. Okay. So there's a property called density. Write this down. Density property of rational numbers. So write this down. We haven't heard of this before, but the concept you should already know. The density property of rational numbers. Okay. It actually works for irrational as well, but let's start with rational. What does it mean when something is really dense? Heavy, packed. Something is sure. Okay. So write this down. Let's see if it, guys, write this down. Here is the Definition of density property of rational number. It says, between any pair of different rational numbers, they have to be different, there is another rational number. Okay, this is a very simple statement, but think about what it's saying. It's saying a lot, really, if you think about it. Between any pair of different rational numbers, there is another rational number. Okay. Say it again. What did you say?
There's an infinite amount of numbers between 1 and 1.
That's correct. Between 1.1 and, I don't know, 1.2 or something, there's infinitely many number of numbers between them, right? It kind of sounds like there's only one number. Is that what it's saying? No, it's really, if there's one number, if there's a rational number between any two rational, then you could keep going forever, right? So very good. So this is saying that there are infinitely number of numbers between any two rational numbers. So it's really dense if you think about it. That's why it's called density property of rational numbers. Do you understand? Okay. So since we know this is true, Molly, what if I ask you something like this? Find a rational number that is halfway between 1/6 and 4/5. Okay. So Molly, how would you do this type of question? Is there such number, by the way? Do you think there's? Yeah. So how would you find a halfway between 1/6 and 4/5? Okay. Make them both of them common denominator. Then what? Subtract. Not quite. Anybody know? How do you find the number between like two numbers? Like, I don't know. What's between 4 and 5? 4.5, right? What's between 4 and 6? 5. What's between 1 and 3?
2.
So how do we do it for 1/6 and 4/5? Yeah. Oh, how do we do it for? How do we do it for 1/6 and 4/5? This is actually easy if you want to find the number right in the middle. How about Sasha? Yeah, add them in. Add them in divided by 2. What's that called? Yeah, you can find the average. And everybody try. How do you find the average? Well, you all try. See what you get. Okay, let's do this. How many people got? So first of all, you add the two numbers. You need a common denominator of 30. So you get 29 over 30 over 2. How do you divide a fraction by 2? Yeah. That's same as multiplying by half. So how many people got 29 over 60? Raise your hand.
I did.
Okay, is this easy? Okay. Any question? Hello? Okay, very good. Now, so this one's not that bad. If you want to find a number right in the middle of those two numbers, right? You just basically find the average. What if I'm asking 1/3 of a number between? So can you find the average?
Yes.
No, you cannot.
No, but
Can you divide it by 3? Because some people say, well, add them together and then divide it by 3, because we want 1/3 away from this, right? Would that give you the answer? No, because I could give you a counter example. Watch this. What number is between 1 and 4? That is okay. What is it? Which rational number is 1/3 away from 1? Between 1 and 4, is that 2? So can I add 1 plus 4 and divide it by 3? Would that work for you? No. If you do it, you get it wrong. You get 5/3. That's not at 2. Okay.
I think I know how.
Does that make sense? We'll do this one. So let me show you. Brian's right. Let me show you by a simple. So we know for sure you can't just add them together and divide it by 3. That won't give it to you, like the average. So let's do it for a simple. Brian got it right. He said that you do 4/5 minus 1/6, divide that by 3, and add it to 1/6. That sounds kind of long, but that is correct. And let me show you why that is true using a simple example. So we verify that you can't just divide it by, right? You can't just add it and divide it by 3 and everything. So now, what is the distance between 1 to 4, by the way? Is there a way to figure out the distance between 1 to 4? How far is from 1 to 4? 3. Okay, well, you could count it, right? But what if they were really far away? You can't really count. What would you do? What's the way of... Yes? Subtract what? 1 and 4 or 4 and 1?
bigger number.
Bigger number minus small number. If you do that, you get a distance, don't you? So we know that the total distance is 3. And what is the 1/3 of 3? How do you figure out 1/3 of that distance? You divide, yeah. You divide it by 3. And as you can see, I get the 1/3 of the distance equals to 1. Now, is that our answer for this one? Our answer should come out to be 2. How do you get 2 from this? Beige.
Because the distance from 1, like 1/3, the distance from 1 to 4 is 1, so you have to add that.
Yeah, you have to add to the starting point, which is 1, because you want 1/3 of the distance from the starting point, 1. You see what I mean? So if you were to add starting point plus that distance, 1/3 of the whole distance, you get 2. Do you understand? Okay, so let's see if we really got it. Okay, what if I had A and B? So instead of some number, what if I had A and B? So your starting point is the one smaller number, right? The one on the left. So here you can see A is smaller than B. Okay. Now, how would you then do for this? 1/3. Okay, how would you find 1/3 of a way from A to B? And your starting point is 8 now, right? Because A is on the left. And it is important to verify that smaller number is on the left, right? Yeah, because they could have switched it around. You're right. You have to actually, figure out which one is smaller and which one's bigger. But if we knew that A was smaller than B, how would you then do it for this, A and B? You first what? Find the distance between? Yeah, you do B minus A and what? Divide by 3. So, and is that all? You add to the A. So this is your formula. A plus, right? B minus A over 3. What does the B minus A over 3 represent? Yeah. The 1/3 distance of the whole distance, right? But you have to add that to your starting point. If you don't, we're not looking for the distance, are we? We're actually looking for that coordinate, where we end up. So you have to add it to that starting point, which is A. Does that make sense? Do you think it'll only work for 1/3 or any kind of like 1/4, 1/5, 1/6? It'll work for so. Okay, if I'm asking, find 1x of a distance away from A to B, who could give me the generic formula for this? Yes.
You do B minus A divided by X plus A.
That's exactly right. But I would actually add A first, plus A plus that. But does that make sense, guys? Right, isn't that how you find? So if you do B minus A, that gives you the total distance from A to B. You divide that by X because that will give you 1x of it, right? And then you add it to your starting point. Does that make sense? So now, do you think we could do this one now? If I want to find the rational number 1/3 away from 1/6 to 4/5, could you all figure this out, knowing this formula?
Yes.
Okay, go ahead, everybody try that. Who thinks they have the... Brian, what'd you get?
17 over 45.
17 over 45. Did anybody get a different answer? What'd you get? 31 over 15. What'd you get?
49 over 90.
Okay. 29 over 30. What'd you get? 4 over 15. Can the number be greater than 1? No, why not? Because? Yeah, so if you got something bigger than 1, it's got to be between 1/6 and 4/5, right? It's got to be closer to 1/6 than 4/5. So, did you all use this formula? 4/5, the bigger number minus 1/6 divided by 3, and then you add that to your starting point. 17 over 45 is correct, isn't that right? If you didn't get that, okay, watch this. Don't you get 24 over 30 minus 5 over 30 when you make it into a common denominator, right? Okay, and then when you divide it by 3, that is same as multiplying by 1/3, right? So you get 1/6 plus 90 over 30 plus times 1 over 3. So you get 1/6 plus 19 over what, guys? 19 over 90, and when 1/6, you need to get a common denominator of 90. So multiply top and bottom of 1/6 by 15. Don't we get 34 over 90, which is what, guys? 17 over 45, right? Any question?